Okay, in the last video I asked you to try to sketch y equals cosecant of x, which is the reciprocal of sine of x. So I've started that process here. I just graphed sine here as a dotted curve. It's not going to be part of my answer, so I want to make sure I don't include it as a solid curve, but it's a helper curve for me figuring out what cosecant looks like. Remember that any time sine is 0, cosecant is going to be undefined, and that's going to be where the graph is going to have a vertical asymptote. Now in this case, the y-axis is a vertical asymptote, and then it looks like I've got vertical asymptotes at every multiple of pi. Once I've got those asymptotes between consecutive asymptotes, I just want to go and flip the bumps, where the high point of cosecant here matches the low point of sine, and here the low point of cosecant will match the high point of sine. So we get these alternating u's that go up and down. Okay. So here's our graph of cosecant. I want to just tie this in with some stuff that we talked about previously. If we talked about the domain of this, before we had just sort of been looking at the unit circle. We had used the unit circle definition of cosecant. Which was that cosecant of little x would be the reciprocal of capital Y. So we were looking for the points where our y, capital Y values would be 0, and those corresponded to those points. And so we said, okay, our domain was going to be all angles x, except angles whose terminal rays would pass through those points. And we had determined that those were multiples of pi. Well, notice how that's reflected in the graph. Multiples of pi are the locations of the asymptotes. So the domain is the set of all x such that x is not equal to n times pi, where n is an integer. Okay. So I can now remember the domain of cosecant a couple of different ways. I can think about the unit circle definition and use the unit circle, or I can think about the graphs of sine and of cosecant, and the domain is everything except where sine is equal to 0, which is the location of these vertical asymptotes. We can also talk about the range. So we had done that previously by just sort of looking at the unit circle and saying, if our y values were taking on values between -1 and 1, we sort of thought, what does that mean about the reciprocals? Well, what we came up with was that the reciprocals were going to be 1 and bigger, or -1 and smaller, and that's really nicely reflected in this graph. So the range is the set of all y values such that such that y is bigger than or equal to 1, or y is less than or equal to -1. So information that we had previously, but here's a nice way to see another way of remembering that and just confirming that we did in fact have that information right. Okay. I can also talk about the period of this, and just like sine and cosine and secant, the period of cosecant is 2 pi. So at this point we have graphed all 6 trig functions. Sine, cosine, secant, and cosecant all have a period of 2 pi. The 2 exceptions to that are tangent and cotangent, both of which have a period of pi. Okay, sounds good. You'll notice I did not mention the amplitude. That's because amplitude only applies to sine and cosine graphs. Sine and cosine are the ones that have a high point and a low point. All the others have these vertical asymptotes, so they're infinitely tall. It doesn't make sense to talk about the amplitude. So that's something that only makes sense in the context of sines and cosines. All right, when we come back, we'll start looking at some transformations of secant and cosecant.